Welcome back, students, into the third unit, SJTV. In the last unit, we have seen video on demand, how video on demand is helpful to the different peoples over the cable. We have seen details about the video on demand, how different business models related to video on demand are being used nowadays by the different peoples. Now let's move towards the next point over this third unit, SGTV. The next point is CCTV. You all are familiar with this concept. What is actually the CCTV and what are different uses of this CCTV? Why that CCTV is mostly used nowadays all over the world? CCTV is being used over a large extent. Let us see in detail what is CCTV. The CCTV, that stands for closed circuit televisions, and it is commonly known as video surveillance. Closed circuit means that broadcasts are usually transmitted to the limited, that is closed number of monitors. Unlike regular televisions, in the regular television, whatever the broadcast is done, that is done over a, it is done for number of clients. Here it is used for limited users. Here the particular CCTV networks, they are commonly used to detect and determine the criminal activities and record traffic that particular infraction, but they have other uses also. The CCTV technology that was first developed in 1942 by a German scientist to monitors the launch of V2 rocket. It was later used by American scientists during the testing of the atomic bomb. This is how the CCTV that was invented. Okay, getting the concept of CCTV. CCTV is, it is a closed circuit television. It is used for limited users, not as the television broadcasters. Let us see in detail how does the CCTV works. In working of CCTV, let us see. Analog and digital systems work quietly differently, but modern CCTV network use conversion software and hardware to convert analog to digital. This process is called as retrofitting. A traditional CCTV system that comprises one or more cameras, analog or digital cameras, each with the lens. They are equipped with an image sensors, recorder, that is either a standard video tape recorder for analog system or a direct video recorder DVR or network video recorder, that is NVR, for different digital systems. The cables here either RJ45 for digital or coaxial cable for the analog. The CCTV we are using here, one or more options or one or more monitors to which the images are transmitted, that is also needed here for the installation of that particular CCTV. Let us see a diagram of this particular CCTV, how that is transmitted from CCTV to different mobile phones or different monitors. A camera that records the images through the lens using image sensor over that particular lens, as you can see in the image, first two cameras. These images, they are often images, but there can be audio also. They are transmitted to the recorders or tape either wirelessly or by the different cables. The recorders, they may use analytical software and other smart technologies to scan the data and send automated alerts to either humans or their system and devices. This video management software, VMS, that records the storages and analyzes that particular video feed. The software is often self-learning software using the machine learning algorithm that utilizes the functionality like motion detection, face recognition, people counting, etc. The monitors that can be passively or actively monitored by software or by the people respectively. The CCTV network that can and should be themselves monitored. This is how that particular CCTV system works here. Now let us move towards the next point, that is different types of CCTV system. What are the types of CCTV system? Analog CCTV, digital and network or IP CCTV. Now let us see what is analog CCTV. This analog CCTV use beyond the BNC connections or on a coaxial cable to transmit the continuous video signals. They are relatively low resolution but cheap and effective than others. There are most peripherals in an analog system. Example, standard coaxial cables, they don't usually transmit the audio analog signal, that they can be digitized, making it more cost effective to do digital even with the older equipment. Also, the image that is required a video capture card, and that can be stored on a PC or a tape recorder. A setup that in an analog HD enables increased resolution over traditional system, that is 1080 pixels, and are also backward compatible with the analog cameras and BNCs. This is how this particular type of CCTV analog CCTV system is used. Next one is digital CCTV system. This digitized signal at a camera level. Okay, this system, they don't require a video capture card, as image are stored directly to the computer, but require a relatively large amount of space to store the recording, so they are usually heavily compressed. Okay, in the third type, network or IP, it is used with the analog or digital cameras. This system, they utilize a video server to stream footage over this internet. The advantages are the possibly or Wi-Fi and audio, the distributed artificial intelligence for analyzing the image footage, remote access, power over Ethernet, and better resolution. Furthermore, here the IP cameras have the ability to contain more cameras in one, which can cover a wide angle that may normally take multiple cameras or camera system to cover this particular thing. All of these three options are still equally in use, with high tendency to IP camera systems and digital video cameras. Okay, getting different types of CCTV. Now let's move to the point that different terms related to the CCTV. What are the technological terms related to the CCTV? First is video encoders. Video encoders, they allow for a migration of analog CCTV system to some network system, enabling users to take the advantage of cheaper hardware and modern features. The software that allows a wired connection and then digitizes the video signal, sending them to a wired or wireless IP based system. This is how the video encoder are used here. Next thing is image sensors. Where the image sensors are used, the cameras uses different types of image sensors, which converts the light into electronic signal. The sensor, they comprises of multiple photodiodes or pixels, which registers the amount of exposed light and converts it into the electrons. The two most popular formats of these image sensors are CMOS, that is complementary metal oxide semiconductor, and CCD, that is charge coupled device. CMOS, these are most cost effective than CCD sensors. Okay, megapixel, they utilize millions of pixels, and CMOS sensor may even rival the quality of CCD sensors also. The CCD sensors here, these are more costly than the CMOS with higher power consumption. CCD scanners are generally the best options for inclement light conditions, means they have higher light sensitivity, and they are quieter than CMOS. While the signal itself is analog in CCD, it is then converted for the transmission by analog to digital converter, which turns the pixel values into the numerical values. This is how the different image sensors we are using here in the camera for the purpose of sensing the light and converting it into the images. Image scanning. What is actually the scanning of the image? For digital CCTV, CCD sensors generally use the interlace scanning method, that is instant exposure, while CMOS and the CCD, that can use either progressive or interlace scanning. Analog camera use only interlace scanning here. The interlace scanning is popular for CCD application. In the interlace scanning, in this technique, it involves the transmission for odd and even TVLs. That is, one stands for lines for an image. Cameras with more than 400 lines, they provide good resolution, and more than 700 lines is considered as a high resolution. These transmissions are repeatedly refreshed, reducing the bandwidth and fooling the human. Sorry. here, by reducing the bandwidth and fooling the human brain into believing that they are seeing a single complete picture, that is, as long as an interlaced recording is viewed on an interlaced monitor, on a progressive scan monitor also, an interlaced image that may look very jagged on a progressive scan monitor. Modern video software that will first interlace scans to convert them into the progressive scan that can be viewed on the analog and progressive scan monitors. Next, progressive scanning. It is popular for CMOS application. In this, the method does not divide the image into the different fields, that is odd and even lines. Instead, the image is scanned and each line, that is field, is exposed on a monitor sequentially. The next term is recorders. The DVRs are usually part of the CCTV system, connecting to various internal components, not on the external networks. DVRs are generally used with the analog cameras in a DVR system. Every camera that must be connected directly to the recorder, while DVR system process footage themselves. NVR systems are encode and process data at the camera level, and then they stream it to the recorder, which in turn is used for the storage and remote monitoring. The NVR system usually here uses the IP cameras. In an NVR system, each IP camera that connects to the same network. These are the different terms we have seen here. Now let's move towards the next point, that is, what are the pros and cons of this particular CCTV. Let us see the advantage of this CCTV, that is, this CCTV enables the remote monitoring, don't require network cabling here, it is highly mobile, and it enables the automation of surveillance processes. While disadvantage of this CCTV is that it can be expensive to buy out of the box, it entails a higher learning curve and are at a risk from hackers also. These are the pros and cons of the network CCTV system. Now let's see the analog CCTV system are having what advantages and disadvantages. That is, it is cheaper and easier in installation than network CCTV with more vendor support availability. The disadvantage is it is having low resolution and more cabling is required here, and don't facilitate the data encryption facility as it is provided in the network CCTV system. Let's discuss the different applications of the CCTV system. The first application of CCTV system is crime management. How the crime management is done by using the CCTV system. The CCTV surveillance that can deter a potential criminals. When a criminals or a crime that does occur, video footage that can help the law enforcement to investigate and later provide evidences for the particular people in a law court. Used in conjunction with the CCTV, audio, thermal, and other types of sensor that can alert the officials to they can alert the officials to occurrence that are out of the ordinary. Example we can see here, fire or a gunshot at that particular location. Means by using the different audios and different thermal sensor and different types of sensors, the particular things they can convey the message towards the law about the fire or the gunshots and on that particular location. For businesses, CCTV cameras that can detect and monitor in-house criminal activities also. Prisons may use a video surveillance to prevent the drones from delivering drugs and other contraband to prisoners. Security cameras are able to monitor areas that are not easily accessible, like rooftops. This is how the crime management can be done by using different applications of this CCTV. CCTV is useful in managing the crimes. Next application we can see disaster management. Using CCTV cameras, the emergency services and rescue workers, they are able to access and monitor different events in real time and to rely on the situation via video to disaster management system. For example, from inside a burning building, from a cave, or from a helicopter flying over a scene. By using this video surveillance over this, the disaster management can be done in a proper way by using this CCTV system over that particular place. The next application is city and community street monitoring. How that particular street monitoring is done in the city or regarding to that particular committee. The cameras at traffic light, they are traffic light and elsewhere in the different cities, they monitor people to gather traffic statistics as well as the evidentiary footage for spending that things. And here to the IoT is a Chicago initiative to collect real time data, primarily weather and environment, about the city. Some sensor nodes include security cameras that analyze the images they record, but in order to protect individuals' privacy, they do not transmit or store these images. In the main, limited numbers are stored for use by senior researchers. In order to develop the computer vision software, the project has met with some resistance from the privacy watchdogs also. The next application is medical monitoring and diagnosis of different things. There are about 43 facial muscles and express people throughout the feelings. Smart software that can identify these expressions like pain, anxiety, and from images more easily, the people can find out these expressions of human. The CCTV cameras, they can also monitor the patients, for instance children or the elderly, to identify the potential medical crisis, for example strokes or an epileptic or asthma attack, that can be monitored and diagnosed by using this CCTV surveillance. The application next is behavioral research. CCTV that is used for the research suicide found that 83% of the people attempting to throw themselves in front of a train, that it showed specific behavior of the people. These were later analyzed from the CCTV footage and are now used to alert the monitor watchers to the potential suicides. The surveillance network, they are also used here by researchers to record the crowd activities in the public places and prevent antisocial behaviors of the people. For instance, cameras, they have been used at schools for security purpose and to record bullying or playground incidents on different videos. Retail intelligence is also one of the application of the CCTV. In this, the market intelligence from the video surveillance of customer, that is being used to analyze buying trends and enable the enhanced strategies. For example, how do people shop? Which aisles do they transverse the most? How likely are they to respond to calls to actions within different store layouts? Heat maps that can show that the highs and lows of the shoppers traffic at the specific locations in that particular store, helping the stores to identify the peak buying times, preferred promotion times, and staffing requirement for peak shopping periods. This is how the CCTV is useful here. This is all about the CCTV. Let us see the future scope of the CCTV. According to the Wesley G. Scogan, in the future, other digital technology shall complement CCTV to create a simultaneous, more autonomous and proactive surveillance process. These technologies include the facial recognition, that is linked cameras, intelligent hardware, license plate readers, drones, policy body cameras, and the IoTs. These technologies will increase the passive surveillance, the ability of the system, rather than people raise alerts, mass surveillance, and greater presence of security cameras, as well as already seeing in China, that could spread to the other countries also. Now let us discuss how the monitoring of CCTV network is done. One of the fastest growing trends in the CCTV security network monitoring software ensures that CCTV systems stay up and running, and it can provide 24 by 7 monitoring of an area and reliable notifications monitoring system that can alert the staff when there is a power failure and automatically switch to backup power supply, constantly check for usual activity on the networks, and it can be configured for different types of uses, risk and requirements. For example, medical or retail themes. Monitoring these networks professionally, it is essential to ensure that compliance with intentional privacy and security regulations to protect the personal data and to efficiently process large amount of image data. Read more about the CCTV monitoring and you will be able to understand what is actually this particular CCTV monitoring is done and how it is done. This is everything regarding the CCTV. We have seen the CCTV, the working of CCTV, different applications of the CCTV, and how this particular CCTV works. Now let's move towards the next point, that is CATV. What is CATV? CATV, it originally stood for Community Access Television, but it is now more commonly known as cable TV. CATV, that is cable TV, or we can call it as a Community Access Television also. The CATV is one of the most common method of transmitting television signals to a consumer's home using the radio frequency signal transmitted through the coaxial cables. More recently, CATV can also transmit over optical fibers, which utilizes the pulses of light to send and receive different signals. CATV that CATV origin date back to the 1924. It was originated before 1924 when some cable broadcasting that was done using cable in European cities. In 1948, community antennas were built where over the air signal that reception was limited. The community antennas received the over the air signal and transmitted it to the household by the cable TV. CATV offers analog and digital channels including high definition. Receiving digital channel requires a cable box conversions here in the CATV. Okay, this is all about the CATV, cable TV or the community access television. It is not morely used nowadays. It was used in early 90s. Now it have been replaced by the digital television and high definition televisions. Now let's discuss about the next point, that is DTH. What is actually the DTH technology? That is direct to home technology. This DTH technology or direct to home technology has acquired a key position in broadcasting the industry in the last decade. The DTH stands for Direct to Home. Direct to Home service is a digital satellite service that provides television services direct to home with a personal dish. The local cable operators, they are not required in DTH and puts the broadcasters directly in touch with the particular consumers. Direct to home technology, it provides a better picture and sound quality. It also offers services like internet access, video conferencing, and emails also. HDTV, that is high definition television, and 3D TVs are the enhanced features of this technology. It also has option to record, rewind, pause the live TVs. Let's discuss the component of DTH technology. What are the different components here in the DTH technology? The DTH, that is direct to home system, that consists of different components, that is dish antenna, LNBF, that is low noise block down converter plus feed horn. Next is coaxial cable and set-top box. The diagram shows LNBF, feed horn, then dish antenna, what is DTH, set-top box and television system. By this diagram you can see what are the different components or different blocks they are, or different things they are present here in the DTH technology regarding the television system. Let's see the components of DTH technology in detail. The first component, that is dish antenna. It is a parabolic reflector. It receives the signal and redirects it to the LNBF, which works as a receiver for signal transmitted by satellite parabolic reflector. Dish antenna, it is a parabolic reflector, that is nothing but an antenna. It receives the signal and redirects or sends that particular signal to LNBF block. What is LNBF? It is low noise block down converter feed horn. Small metal horn antenna on the dish is called as feed horn. It collects the signal from dish and amplifies the signal bouncing off the dish and filters out the noise, that is signal not carrying the programming. As you can see here in the diagram, what is LNBF? The LNBF you can see in this diagram. Let's see the next, that is coaxial cable. Coaxial cable, it is a cable that connects the mini dish and set top box together. DTH set top box, it is unlike the regular cable connection, decodes and encrypts the transmission data and converts this signal into the audio and video signals as required on the television set. These are the components that are needed for the direct to home technology use. The architecture of direct to home technology you can see in diagram, that is satellite, broadcast center, multiplexers, modulator, encoder, receiver, that is decryptor. Sorry. The architecture of direct to home that includes satellite, broadcasting center, multiplexer, modulator, encoder, and DTH receiver, as you can see in the diagram. Now let us see everything one by one in detail. First one is satellite. A geostationary satellite that plays an important role in direct to home system. That satellites have a much larger line of sight that range as they are higher in the sky than the TV antennas. It transmits the signal to the DTH antennas. That is the use of satellite here. Next one is broadcasting center. The broadcasting center is a central hub of system. The television provider receives the signal here from the various programming sources and then the beams a broadcast signal to a satellite which are a geostationary orbit. The satellite receives the signal from the broadcasting stations and rebroadcasts them to the ground. This is how the work of broadcasting center is here. Next block is multiplexer. Multiplexer is a device which transmits the information of many channels in one channel. It is a part of broadcasting center. In the broadcasting center, the multiplexer compresses all the data or the frequency signals into the one single channel and transmit it to the geostationary satellite. It sends the signal channel to the modulator. What is the purpose of modulator here? The modulator used here is for the purpose of modulation. Modulation is a process in which the information signal is imposed on a carrier signal which is of high length. Then the modulator modulates the signal and sends it to the encoder. The encoder block present here encodes the signal to transmit the signal. Okay, the satellite that sends the signal to the DTH antenna which further transmits them to the set-top box. After that, there is a DTH receiver. DTH receiver is the end component in the entire DTH system. This DTH receiver decodes and descrambles the encrypted signal. For unlocking the signal, it needs the proper decoder chip for the programming packages. The service provider, they can communicate with the chip with the help of satellite signal to make a required operation to its decoding that particular program. This is the architecture of direct to home and different blocks they are present in this particular architecture of direct to home. We have seen in detail what is the work of satellite, broadcast centers, multiplexers, modulators, encoders, and receivers here in the direct to home technology. Getting the architecture. Now let's see how does the direct to home technology works here. The direct to home technology, as you can see in the diagram, this is the schematic representation of working principle of the particular direct to home technology, which consists of the satellite present. The satellite transmit the encrypted signal towards the receiving antenna, that is LNBF, as we have seen in the last diagram also. You can see in this diagram this LNBF. That signal received by this receiving antenna is sent to the set-top box that is present at the home of the different consumers. The use of set-top box is for the purpose of decryption. This decrypted stream that is provided, or that is sent to the television set, so that on the television set, whatever the data that was transmitted from the satellite, or whatever the program that was broadcast from the satellite, that can be seen on that television set properly. In short, we can say that the satellite which are located approximately 35,700 km above the earth's surface, they transmit the signal to the broadcast stations on the earth's surface. Whatever the broadcast center receives the signal and transpons on the satellite, they helps in establishing the communication channel between the transmitting and receiving unit. The satellite rebroadcasts the signal which are encoded here. The encoder that converts the data, audio and video signals into the digital formats, and these signals are mixed or combined by a multiplexer. There will be a small dish antenna and set-top box at the user end to receiver that decodes and views the numerous channels. This is the working of the particular DTH technology. Let us see some of the advantages and disadvantages of the DTH technology. The advantages of DTH technology, they are greater service coverage. DTH technology provides the greater service coverage. They gives the more channel we can are broadcasted from there, and we can access that different channels. The better signal quality is present in the DTH technology. Multiple language options are also present. If you want to use different languages, and if you want to watch the different language programs they are broadcasted, you can use here in the DTH technology. Pay only for the channels and service that the user wants. This service is also being provided by DTH nowadays. In before days, this service was not provided by the DTH, but DTH nowadays is providing the service for you have to pay for the signals only channels that you want to watch. The applications such as parental lock, pre-locked pay per view, and impulse pay per view, these things are also the advantages of DTH technology. What are the disadvantages? Disadvantages of the DTH technology is that one of the major problem for the subscription of DTH technology is unable to view any channel during heavy rains due to the weak signals. That is the disadvantages. When there is a rain, you cannot watch the any channel. Not a single channel is that can be watched by you when there is a heavy rain. Changing service provider is not easy, as the user has to pay additional cost to buy new set-top box from new service provider. There are different service providers for this set-top box. If you want to switch from one provider to another, then you have to buy a whole set-top box providers of different provider. Means if you are using one provider, switching to another, the one that you are using now is of no use for the another provider, so that you have to simply switch to that, and you have to buy a whole set of that set-top box here. This is everything regarding the DTH technology. We have seen in detail advantages, disadvantages, applications, the working of DTH technology, and everything regarding the DTH technology.